Okay, so good afternoon to China, good morning to Europe. Welcome, I'm Martin Schübel. I'm Associate Professor at the Technical University of Denmark, and I'm teaching there as a professor, and I'm changing teaching to Chisel. I did change, and so that's my topic of today. I was beginning of last year, on the last Chisel Community Conference 2020. And I was asking the question, is Chisel ready for class? Because I was just about to switch. And as I can now say in the next CCC, I can say a bold yes, and it works very well. So I could stop, right? Okay, hardware courses at Technical University of Denmark, or for short DE2, this is a Danish acronym for it. So we have Digital Electronics 1 and 2, which is mandatory for electronic engineering students. It changed a little bit because Digital Electronic 2 is not mandatory anymore since today, was this year. We used VHDL till 2019. So Europe is very VHDL oriented. So we came VHDL. We would need to change anyway because VHDL is dying a little bit. So it would be either System Verilog or Chisel. Digital Electronic 1, I'm not involved with this one. This is still done in VHDL. It's not me, but I changed Digital Electronic 2, the second semester course, to Chisel last spring semester. So I can report of 2 semesters of teaching second year students, second semester, first year students in Digital Electronic with Chisel. We have several other hardware courses in our section on hardware, on this asynchronous design, on arithmetic processes and computer architecture, whatever. And most are still using VHDL, except an advanced computer architecture course, which given by me, and another one I will report as well. So people are a little bit reluctant to switch to Chisel. It was also a little bit risky for me because my colleagues didn't really so excited about it. But anyway, further uptake, actually there's a computer systems course. This is third semester, I think, yes. Introduction to computer architecture and everything, all this basic stuff to software technology students. So this is a complete different bunch of students. This is a software guys learning a little bit how a computer works. They have no hardware experience at all. They learn what a gate is, what transistors is in that course. And then they need to implement the small, tiny processor as a state machine with data paths. And then they switched to Chisel as well last semester. I'm not involved in this course at all. I got the report that it worked very well with Chisel. So we are now using it in 2 mandatory classes and in some advanced classes. So my Digital Electronic 2 class in spring 2020-21, it's kind of a very early class. So it's quite unexperienced students related to computer science, to programming, to everything. So it's a second semester in electrical engineering. They had no programming experience at all, except writing a few lines of VHDL. So in their curriculum, the first thing that C is VHDL. Not Java, not C, it's VHDL. So they start out with VHDL in the first semester. And then in the second semester, they are having Digital Electronic 2, and also introduction to programming with Java. So they learn in parallel, writing software in Java and describing hardware in Chisel. And I tried to coordinate a little bit with the Java course, but sometimes I had to jump ahead. I had to use classes and objects, even if they have not yet learned it in Java. Because most of them are so typical Windows users, so no command line experience. Whereas Chisel, you usually use SPT or something. And I was a little bit afraid of how the Chisel setup work well under Windows. So because it's largely ignored by the Chisel, at least development community, which is okay because we all switched at some point from Windows away, but it worked very well. I just had to try it out in a virtual machine and write some description and have some hand-holding explanation to students, and yes. And we had in the first semester, as a 2020, we had a physical lab where machines were installed according to my rules. So this worked out. So students didn't have to install it on their laptop. But this changed a little bit a few weeks later. So what did they know? So they had digital electronic 1 and 4, so they had basic digital circuits, they did Boolean algebra, which is very nice. They do still this manual optimization with Carnot maps by hand. I'm not sure if this is good to learn, but never mind. And they did basic VHDL to write this tiny state machine. And each group has its own FPGA board, so we are very much focused in getting hands-on on physical hardware, because it's more exciting than just living in simulation. So this is a Xilinx board, so they know how to press the buttons in Xilinx Vivado to generate a bit stream, and usually they have their own laptop these days. Easygoing with IntelliJ, so I think this is a great IDE for Chisel and Scala. I tried to adapt Eclipse because you're using Eclipse for Java, but doesn't work very well with Scala, but actually I think it's a good idea to have a little bit of distance between the Java environment and the Chisel environment. So using Eclipse, then they're writing Java, so using IntelliJ, then they're maybe in the Chisel Scala mindset. Yes, and I'm giving them all the files to start up, which is basically a build SPT and one Scala class. And I tell them how to import a project from build.spt, which is relatively simple. And then I try to slowly introduce them a little bit to use a command line interface. You just use a terminal in IntelliJ, and then I tell them type SPT run or type SPT test in the terminal window. So getting them slowly into this more advanced user mode. And I give them lab material, one Chisel project per week, because you have to import it new to organize it. Yes, teaching material. Some of you might have seen this. There's a book out, Digital Design with Chisel, which actually got a push. When I decided to switch to Chisel, I really sat down a few weeks and trying to get out a version. And as you see, this is also available in Chinese, in Japanese, and in Vietnamese. Yes, it's an open access, open source book. So if you find an error or you want to contribute something, you just do a pull request. It's on GitHub. And this is a surprising thing. If you do open access projects, some of you might have experienced this. I got free translations, as you've seen before, just because it was open source. I'm very grateful to all those people who did all these translations. If you want to get a printed version, you can just tell Amazon to print it for you. It's a few dollars. And actually, this on-demand printing, Amazon prints exactly when you order one, it prints one. So this is a very agile way to publishing. In the early days, everything was printed ahead. So doing a new edition was very cumbersome, expensive, but now it's just uploading a new PDF. And one day later, after some manual check, it's available. So you can actually adapt to the agile hardware development Chisel by doing agile publishing of a book. Yes, and the teaching slides sources are included at GitHub, and also the generated PDF are also available on the website. So if it happens that you want to use Chisel for teaching digital electronics or somewhere, please take all these resources and use them. Lab material, so getting hands-on. First week is just getting everything set up, remembering from last semester how to start Vivado, how to get Java with JVM, SPT, everything running. And then we started on slowly with simple circuits. I give them the tester and they just had to fill in lines. It's similar to the older Chisel tutorials. The bootcamp did not work so well because the installation of the Jupyter with Scala in Windows was too painful for second semester students. So I built it up just as plain GitHub resources. And then they're building towards a vending machine as a final project. Final project, this is FPGA board we are using. It's a Xilinx, little bit oldish board. So we're having these buttons to press and then adding some coins and so on. It's a basic vending machine, nothing special. So they have to do the segment encoding as the first part, then they do display multiplexing. This was always a little bit painful in the years before because they have to learn how to generate timing with counters and so. And I think with Chisel it was a little bit less painful. And then they do state machine with data paths and running it in FPGA. So I did the exercise myself last year just to see how it is. I wrote this in Chisel and it took me 2 hours for the whole thing. Of course, I know what the hardware is about because it's easy hardware and I know a little bit of Chisel. And it was roughly 200 lines of code, the whole project, including a binary to PCD conversion. And I had a VHDL version, which was not done by me, so it's not easy to compare. It's a little bit more verbose, more than double the number of lines of code. Okay, so everything fine. People started to learn Chisel, and then came the lockdown in the middle of the semester. It was kind of just one day before I had another lecture, and we had labs, and there was a hard lockdown. No more allowed to go to the university. No group work. Students were not allowed to meet in groups, but they had usually one FPGA board per group, and it's hard to share. I mean, yes, you can send out around bit files from Vivado and everything, but it's very hard. So the question is, can Chisel, Scala, Java help me in this situation? Can I do something around it? And I would like to share something else. So I went back to some old knowledge on writing GUI in Java with Swing and all this crap, which I did ages ago, and found a nice Scala wrapping around Swing. And then I said, okay, let's try to write a small simulation of the FPGA hardware and the board. It's not very pretty. So actually, this is within Chisel environment. Instead of running a Chisel test, or it's a Chisel test by itself, whatever, I'm just running here a simulator. So this is very rough with this board. We have this, here's these switches here to set a price. We have these buttons here. They're connected by default to an LED. This is wrong, but it's just the top level as it is. And I have the display here, and it also simulates this multiplexing. So if you do nothing, you just have one digit, you have to multiplex themselves. So this saved the day, so to say. So people now without an FPGA board were able to write the vending machine. And actually this was also, some appreciated even with the board, because it's way faster to actually debug the code instead of generating a bit file. Okay, lab exam outcome. So most groups finished in time, 2020 spring. I was hoping that they will finish faster, because Chisel is faster, that's for sure. But they didn't. They finished roughly the same as the years before when they had to struggle with VHDL. But I think actually we had a lockdown in the middle of the semester, and everyone was super stressed because this was all new and getting everything set up. So I think the slowdown during the lockdown, the stress on the lockdown actually compensated, or Chisel compensated for this when they ended up even. This semester, it just finished this semester. I just corrected exams last week. Students finished earlier. They are already used to work at home. We are having a lockdown the full semester. We started online and everything is online. So many groups finished earlier. Many groups actually adding stuff because they had fun doing these things, doing hardware. One had an Easter egg to run Snake on the display when you reach 2042 with your coins. And maybe I should beef it up a little bit and asking for more hardware. And exam as well, it was very good results, never ever so good results. It was an online with open internet exam, so maybe they were now better at cheating, could be. But when I looked at the lab reports, I think a lot really learned a lot. So it might be a mix. I will never know for sure. Good. Student reactions. So most of them, I think 95% something, were very happy to switch from VHDL to Chisel. This is way more in line with using Java. So Scala, you could say it's Java++, like a little bit different syntax, of course, but it's Java plus functional programming, and Chisel is on top of Scala. So it feels not so far apart than VHDL with the syntax from the 60s, 70s, whatever. I don't know exactly. And maybe it actually was good, looked good, because they had VHDL in the first semester, have seen how painful it could be to describe hardware and then enjoying Chisel. Maybe this is good, and maybe we should just keep it. And then they can say, I can VHDL and Chisel. And then some reactions. I had an questionnaire in the midterm that we have to do it at DE2. to steer our teaching if possible. So there's a few numbers. Let's say environment nice of outside of Vivado. If you use VHDL or Verilog, you're running in Vivado. Usually it feels intuitive and so much better than VHDL. Someone is in love with Chisel. And yes, and a few quirks. Some had to work as what else? A shame that we are not using professional context, but maybe this changes. I hope from all our community we are getting Chisel into professional context, and something is good for learning digital design and future of it too. And so it's enjoy using it, but not ready to replace System Verilog. Someone looks like he has a System Verilog background. And then this is a kind of a funny statement. I just picked it out there. I had a lot of statements here, just to pick some nicer, okay, some of them. And then some more comments from the final report, which I just read last week. I handed in a few weeks. So this is really at the end of the semester. The first one was in the middle where Chisel was very new, and this is after 13 weeks. So they have joy working with it, found joy for digital design, new joy. I think to say, but I think they had a little bit painful in the first one. Yes, and again, comparing to VHDL, extremely easy, easy of use, quick and efficient implementation is Chisel. So I think it's worked out for a second semester course. Students just learn to program software and hardware in parallel, learning how to describe algorithms for sequential execution in Java and for parallel execution in Chisel running on FPGA. We have this textbook for sure, that's good. We're also using a Intelli standard digital design textbook from the first semester on, so I don't need to cover all these low-level details. I can focus a little bit more on how to describe this digital electronics in Chisel, but it's not a Chisel course. And some students actually, they mistook me a little bit and thought it's like a Chisel course, but no. Yes, end of the day, Chisel is Scala is a little bit complex as an almost first programming language, so I avoided Scala, circuit generation, everything. I did a little bit, I showed them how to do a binary PCT translation table, and some picked it up. Okay, thank you very much for listening, and might be open for questions.